Welcome you to my presentation for IEOM 2020 conference. My name is Ziout. I will present to you our paper regarding the use of Taguchi method as an optimization method in construction industry. Actually, this paper came out as a result or an output of the term project conducted in a quality engineering and management course in a Master of Engineering Management program. In this course, we urge the students to go further and explore the application of the theory they have studied in the course and explore the possibility of implementing their theories and their knowledge in the industry. So the paper is about the application of Taguchi design and quality improvement for construction industry. A group of authors, myself, Ziout, Jabra, Qudeiri, Mohammed, Osama, and Hana, as a research team, were dedicated to the output of this paper. Would like to go with you through the outline of the presentation. I will introduce the topic for you. I will quickly touch on the literature that we have reviewed to see the background of the problem, and we will share with you our methodology to tackle the assumption that we had, and also we will discuss the factors that we landed on and their levels also, and we will be explaining the statistical analysis that we have used to come up with the conclusions of our research here. And we will touch quickly on the sustainability and the economical and environmental aspects of the suggested process that we have. And by the end, we will conclude with some conclusions that we came out of from this research. So in general, concrete and construction industry is a viable industry, is very advancing, and it's especially here in the United Arab Emirates, a lot of construction is moving on here. As an example, Burj Khalifa Tower, which has consumed almost more than 500,000 cubic meter of concrete and volume. So basically, the concrete and the construction industry is require a lot of attention and improvements to save the environment and reduce the cost as well. In general, concrete is made of aggregates, cement, sand, water, and some additional materials to give the concrete certain properties. What we are suggesting here, and we would like to improve in the concrete mixing process, is to add a recycled aggregates as well as a dune, which is desert sand that's available as for free here in the country. And also we would like to examine and test the addition of steel fibers in the concrete mixing. So basically here, before we get into the experimentation, we did literature review on the topic and see what has been done regarding adding recycled aggregates, regarding adding steel fibers. But honestly, the dune sand or the desert sand is something we are suggesting here in the paper. So not much literature found on addition of the sand. Well, just to go through with through the literature review regarding the recycled aggregate and its addition, or regarding its addition to the concrete and the effect on the strength. Here we have a couple of research has been done and verified and tested the addition of recycled aggregates. For example, Kakira et al. In 2012, they found out that 100% of recycled aggregate decreased the compressive strength by 24% of the compressive stress of the samples. Yahya et al. 2015 also, they ended up with a conclusion saying that 30% of the recycled aggregate will will not do much change on the compressive strength. Actually, Zhao and Chen, 2017, said any percentage more than 50% will start dramatically affect the strength of the concrete. So in general here, we can conclude that the addition of recycled aggregate has a bad impact on the strength of the concrete. Why the steel fibers and concrete strength effect is studied by a couple of researchers, Thomas and Ramwamawi, 2007. They concluded that the percentage of 1.5 of steel fiber increased the compressive strength by 10%, which is a good addition here. AlAin also, they found out that adding 1% of steel fiber increased the compressive strength by 8%. On the other side, Song et al. 2008, they found out that adding 1.5 of steel fiber increased the compressive strength by 12%, while if you increase the percentage to 2.5, the compressive strength will be decreased instead of increasing. So there is optimum value here need to be added. Also here we have a couple of studies regarding the addition of steel fiber and recycled aggregate together at the same time. Basically, here Gao et al. And others, they have concluded that using steel fibers with recycled aggregate increase the compressive strength of the concrete in general. So basically here, what we are suggesting or what we are adding here, we would like to study the effect of recycled aggregate, the amount of steel fibers or the percentage of the steel fibers, and the addition of or the replacement of the normal sand or the manufactured sand, let's put it this way, with dune sand or desert sand, which is available for free. So in terms of research objective, our main objectives here are to investigate the variability of the factors, like what are the optimal percentage, what are the optimal level, let's call it level, the optimal level of each of these 4 factors to get the optimal compressive strength. And also here we would like to identify the impacts of these factors on the concrete compressive strength and specifically. And we want also to find the optimal combination of these factors if they have a mutual effect between each other and how they affect each other, and ultimately how these factors affect the quality as well as the compressive strength of the concrete. So toward this end, we have followed an experimental approach, ACI 211.1 mix design method. Was used to determine the proportion of the mixture as well as the mixing and the testing procedure. So basically, referring to the literature and the practice, we have identified these 4 factors here, recycled aggregate, dune sand, percentage of steel fiber, as well as the duration till the test is from the day of casting till the day of testing, and we have come up with 3 levels for each factors. These levels are selected based on suggestions in the literature as well as the experience here. So, for example, for recycled aggregate, we have 0%, 50%, and fully 100% recycled aggregate. Same as for the other factors. Well, the response variable that we are measuring here is the compressive strength. We are watching for the compressive strength because the main property that is watched for concrete. Basically, concrete in construction is used for to take the compressive load. So basically, the compressive strength is our response variable. To avoid or to eliminate the error in experimentation, 3 replicates is made and measured for each experiment in our design here. So for example, here's just to demonstrate, here is like one examples or sample of experiments that has been done, for example, at a zero recycled aggregate, 100% dune sand, 0 steel fiber, and at 3 days tests. We have a 3 rep of these experiments. The first one gives us 13.7 megapascal as a compression strength, 16, 15, and the value that we will build our analysis based on is the average of these 3 replicates. So what kind of statistical analysis that we have used here? We are, since our target is, or our objective in this paper is to investigate or to prove that Taguchi design would work fine in this case, we have to compare it with a standard statistical test, which is the full factorial design. Basically, a full factorial design for this experiments, we have 4 variables, 3 levels. Basically, we need almost 81 experiments. And here we have conducted these in the in a factory where one of the research team is working there. And we got the data required from these experiments. At the same time, also we run a Taguchi design, and Taguchi experiments also almost 27% is needed. And also we ran these experiments and conducted the data collection from these to use them for comparison between the full factorial design and Taguchi design. And then we conducted a comparison between these 2 techniques. Well, Minitab is used to analyze these data. A regression model is generated here. General one is generated here. And then definitely test of hypotheses are used to test the effect of each factor level, if there is a difference or not, and so forth. Also, the model assumption was verified through the normality tests, and it seems that it follows a normal distribution here. And this analysis is shown by the Minitab before the optimization, where the effect of a single factor and the two-way factors and three-way factors, four-way factors here is considered, and the p-values of each one is calculated here. So after optimization, when the based on the p-value over here, it was found that only one-way factor and two-way factor were the most influential one. And also here we have conducted a couple of, based on Minitab such available tools here, we have conducted a couple of model assumptions and verifications like normality test and other tests here to validate the assumptions of normality that we have assumed. Okay, and the final model under the full factorial design, we have ended up with this model where A is the recycled aggregate, B is the dune sand, and C is the fiber fiber contents or percentage. D is the testing or the time to testing, and here is the final model based on the full factorial. As we see here, the R squared value is high, 94.3, which is very good one. So here would like to discuss our results and findings that came out from the full factorial design. If we are studying the effect of the factor levels on the compressive strength in megapascal, we would see here, for example, for the recycled aggregates, the 0% has the highest, then 50%, and as you see here, kind of a linear relationship with the percentage of the aggregates, recycled aggregates. The lowest is the better. For the dune sand here, the full factor shows that 50% would give a better choice or better compressive strength, while the steel fiber addition here, it looks like there is an optimal value around the 1.5%. For the testing, for the time till test, 3 days, 7 days, 28, it's very obvious that if you give the concrete longer time to cure, it would give a better result. As per the test, 28 days is the recommended, and it seems that it's the time required for the concrete to acquire its full strength at 28 days. Well, then based on that, the selection would be, for example, here 50% recycled aggregate, 100% dune sand, and 1.5. It will give you a yield strength of 35 megapascal as a compression test, compression strengthening. Okay, so these are the results came out from the full factorial. We would like here to test the Taguchi design, the Taguchi analysis, and the motivation towards Taguchi is the reduced number of 81 experiments in factorial analysis down to 27 experiments in Taguchi design. So again, Minitab is used to establish the plan for the experiments. Also to collect and analyze the data. For example, here is a summary table for the 4 factors and the 3 levels, and here is the average of the compressive strength of the samples that collected this method. Also here we have tested, or we have collected data regarding the signal to noise ratio to sense or to measure or assess the sensitivity to variability in the factors. So both are documented here. And also, if we look at if we give a close look at the effect of the factors and the mean of the strength, we see a very similar results to what we have seen in the factorial analysis. This also shows clearly here as the lower percentage of recycled aggregates is the better. Dune sand percentage may be a little bit different here. 50% shows worse than 0%, while 100% of dune sand is giving a good increase in the strength. The steel fiber also behaves the same. It sounds there's an optimal here, as well as the time till, or the curing time till the test time, 28 was showing the best among the all. Similarly, for the sensitivity, the signal to noise ratio here, it follows almost the same as the effect on mean. So if we would like to conduct a comparison between full factorial results, recommendations, and Taguchi results, basically, as we can see here for the recycled aggregates, almost the same recommendation, almost the same behavior. For the dune sand, except here the 50% of dune sand, the other results are very comparable. and the steel fiber percentage is exactly the same recommendation, same as for the curing time. From this comparison, we can confidently say that Taguchi design would be a good replacement of full factorial. It will lead to the same conclusions, will give the same results at the same time at a lower cost of experimentation. Almost 1/3 of the number of experiments needed to come up with the same conclusions here. We can get it with the Taguchi design at a lower cost of experimentation. Well, here we would like to shed a light on the usefulness and the sustainability of the our suggestions here of adding aggregates and dune sand and steel fibers. Definitely, the concrete uses non-renewable materials. Yes, it is abundant material, but still it's not non-renewable. So if we can use the recycled aggregate, that will first of all save the environment, also save the pollution that comes out from demolishing processes around the world. So basically, it's saving and saving cost as well as saving the environment. An overall range. Okay, so basically here our concrete mix is an economical and sustainable to environments, since the recycled aggregate and the dune sand can be obtained easily and for free, especially here in the United Arab Emirates. The desert sand or the dune sand is available with a very minimal cost, mainly just the transportation cost. So in conclusion, we can say we are able to come up with a new mixture that gives a good compressive strength, and we were able to identify the optimal values of these 4 factors. And our conclusions here is to use 50% recycled aggregate compared to non-recycled one. To use 100% dune sand instead of using the manufactured sand, and to add 1.5 steel fibers, and keep the mixture till 28 days, where it gives the optimal value. Basically, once you cast it in the sun, then it stays forever. So definitely it will pass the 28 and it will get the maximum strength. So basically, these are the 3 factors and the the 3 constituents of the new mixture that we are suggesting, along with their values. It's a promising step toward implementing recyclable material. So we can keep the good compressive strength while improving the utilization of the recycled aggregates and the demolishing outputs. So as a future work, we are suggesting the additional investigation of the tensile strength. On the other side, we have touched on the compressive strength, but we didn't test the tensile strength. Maybe the addition of the steel fiber will improve this property. Also, the addition of other additives to improve the quality and the strength of the concrete. That also will add to the conclusions here and will result in a mixture or concrete that is comparable to the one that uses virgin aggregates and manufactured sand. Our references that we came up, more details, you can find it in the paper. Thank you.